we got into these things, and we were searching for specific values. And as we were searching for specific values, we were asking ourselves what that statement said. What the statement here says is, what angle has cosine negative root 2 over 2? When you did that, when we originally looked at these things, we were searching within specific parameters. Today, what's going to change is we still start with a specific parameter, but we add a little bit more to it. Okay. So when we did this last week, cosine negative root 2 over 2, cosine's negative, we would find that within the second quadrant. We okay with that? We also know that when you have root 2's over 2's, it's got to be a 45, 45, 90. All right? So we would draw our 45, 45, 90. And my reference angle is the up 45. Okay? Now, the angle that has the up 45 in the second quadrant is obtuse because it's cosine. But is it? Remember, this is all radians. Everything is in radians. So many of you guys kept put things in degrees last week. So make sure we go back to radians in this case. What is that in radians? Yes, sir. 14.4. So you're up pi over 4. So when you come over, you're at 3 pi over 4. Good. Okay. Now, what's going to change today is I'm also going to ask you, where else is cosine negative? What other quadrant is cosine negative?
That one.
Do you remember this? Cosine is what is your x value, right?
Yeah.
So where is x negative?
There.
So to get a negative cosine value means I have to either be in the second or the third quadrant for this. So what I would do is I draw my other triangle.
So that'd be negative 3.
It's still down 45. What's going to change ever so slightly today, as opposed to just finding between 0 and pi, I'm going to ask to find all possible values between 0. Oops.
It's not on there.
Both ones are negative.
Yeah, I'm sorry. We're trying between value to this and 2 pi. We're going to find all possible values basically within what's called one revolution. Okay. So you still did the same thing. You figured out cosine was negative root 2 over 2 was at 3 pi over 4. It's also, when you move it down pi over 4 from pi, that would be, excuse me, 5 pi over 4. So there's going to be 2 places where cosine has negative root 2 over 2 for a value. Okay. That's what we're looking at. Because your reference angle is pi over 4, so you went up pi over 4, so you also have to drop down pi over 4. We're just utilizing reference angles to go around. Okay. Yes, ma'am. 3 pi over 4 and 5 pi over 4. Oh, this was just x was negative. That's all this was here. X was negative. I was just writing that. And my handwriting. Yes, sir.
So is 5 pi over 4 like from the 0 to go?
Yep. This is what it's going to happen as we get into this further. You're going to be solving within one revolution. There's 2 different versions of this setup here. We're going to have what's called within one revolution, and eventually we'll also start talking about what's called general solutions. Those kind of have the same basic starting points, but then when you get to general, there's a few extra steps. Okay. Same idea here. When I have what angle has a tangent of root 3 over 3, is that value positive or negative?
Positive.
Positive. What quadrants is tangent positive? First and third. Good. So first thing I would do is figure out what angle gives me root 3 over 3. Remember the trick. When you see root 3 over 3 or root 2 over 2, unrationalize it. What would that look like unrationalized?
1 over
1 over root 3. Good. So that means your opposite's the 1, you're adjacent to the root 3. What angle has?
30.
Correct. Which is?
Pi over 6.
Oh, pi over 6. I thought you said pi over 6. I heard a 6. So I'm like, so your reference angle in the first quadrant is pi over 6. So first answer is pi over 6. You guys just told me it's also positive in the third quadrant. What's the angle that has a reference angle of pi over 6 in the third quadrant? How much?
7 pi over 6.
Very good.
So it's that, and then it's just whatever to the
Yep, in this case, because tangent's positive first and second. Okay? So far, so good? All right.
Wait, so we're not doing the all students teach chemical?
Well, yeah, because we did. Where is it positive? Teach, third, first, all, third.
Okay, so we do the one that's positive, and then it's all.
It could be negative. If every problem, you can't,
Yeah.
you like to think in terms of this is going to happen every time. Stop doing that. Okay? So here's what happens. We start solving equations. What this is going to allow us to do is we'll be able to solve, let me move this over, this equation, 2 times the sine of x minus 1 equals 0, over the idea of 1 revolution. We're solving for all possible values of x between 0 and 2 pi. You include 0, you don't include 2 pi. All right? So, past 3-4 days, we haven't been using x values and theta values with our sines and cosines and square roots and stuff like that. Now we're going to rewrite those again. Okay? Because there isn't as much of the simplify verify part of this. It does utilize it eventually, but I wanted to start slow. Okay? Solving equations, what do you have to do?
Add 1.
You have to, add 1, you work backwards. Everybody okay that you have to add 1 divided by 2? So your sine of x is 1/2. Now remember, how do you get the x value here? What do you have to do with the sine? You have to inverse it. So this turns into the question, what angle has the sine of 1/2? Okay. 30, 60, 90. Are we okay with that? Because it's 1/2. There's no root 2's here, so it's got to be the other one. You draw it. 1 and a 2. Well, that's got to be my 30, so that's my pi over 6. Where else is sine positive? Second quadrant. Second quadrant has a reference angle of pi over 6, therefore it is? Very good. And those are your 2 possible solutions in this case within 1 revolution that have a sine of 1/2. Yes, sir. Yes, sir. Okay. That's up. No. Well, okay. What'll happen with general solutions, it's a completely different ballgame. Think of it this way. Put your pencils down for 1 second. How long does it take me to get back to pi over 6? From pi over 6. Which is how much pi? So, every time I go around however many times, if I want to say 5, this would be 10 pi, correct? So I go around 5 times. I'm still going to wind up at the same spot. That's a general solution. So that's kind of what you were asking at. How long does it take me to get to here?
Plus 2 pi.
Are these 2 equidistant from one another?
Well, from
All right, I'm sorry. From here to here and then from here to here. They're 2 different distances.
Yeah.
So that's why we can't say they're the same distance, equidistant apart. So that's where general solutions come from. We're not there yet. That's a whole other explanation that I'll go through and re-explain. Hopefully live, but if not.
So the points themselves are equidistant, but the revolutions are
Correct. You have to be equidistant from one to the other and the other to the other. Yes, sir.
So wait,
Depends on the, well, yeah. Same idea. Again, I think when I was writing this out, my handwriting got a little. We're solving for all possible values of x between 0 and 2 pi. I'm looking at all possible solutions within 1 revolution today. I'm not going to change from that. So not every question is going to have that bit on there where it says between 0 less than or equal to x less than or equal to 2 pi or theta, however it's written. Okay. So we have 4 cosine of x plus 1 equals -1. What do you do first? Subtract 1 divided by 4. So we're at cosine of x is -2/4, otherwise known as -1/2. Correct. Yep. Falls back into the same scenario. Once you get to this this spot, you're going to write out what angle has -1/2 as a cosine. Well, if cosine's negative, we would always start in the second quadrant. So we would draw it to the second quadrant. My adjacent, excuse me, is the -1. There's my 2. We also know that it's negative in the third quadrant. So what angle has an opposite of the root 3? 60. Yes, sir.
All students think calculus. Where's x negative? Third quadrant. Second and third quadrant. Pi over 3.
Yep. The reference angle is pi over 3. If I'm up pi over 3 in the second quadrant, that means this guy is 2 pi over 3. If I'm down pi over 3, yep, into the third quadrant, I'm at 4 pi over 3.
Wait, wouldn't it be over 6 since one's up? No? Never mind.
Let's go outside, yeah.
I mean, you could do like this is all we're doing. What's broken into the hard problem?
I get there. You guys know this. You know, like scaffolds, right? Same scenario. Square root of 3 times tangent of x subtract 1 is 0. I just didn't write within one revolution. This is all still within one revolution. As you get going into these things, you will start to get pretty comfortable. Hopefully, you'll get comfortable with skipping a few steps from here to there. It's fine if you don't, not a big deal. I see this and I know right away it's going to be 1 over root 3. And when I'm solving this stuff out, I am not going to rationalize anything. Reason being is because there's my opposite adjacent. I don't have to undo it, okay? Whereas before you would ask you what angle has the tangent of root 3 over 3, you guys would unrationalize it to work with. Here it's already unrationalized for you because you're solving. So you go back to the same idea, what angle has the tangent value of positive root 3, 1 over root 3. Where's tangent positive? First and third. 1 over root 3, so we draw it real fast. That's my 1 by root 3. Well, that's got to be a pi over 6, and it's down here also. Oh, wrong quadrant. Very good. Notice how it's eerily similar to inversing values before. You're just basically adding one extra step. Yes, sir?
So if it was like a negative 1 over root 3, basically like, so it would be in the second and fourth quadrant.
Yes, sir. Very good. Yep, and we'll get stuff like that. I'm getting there. You guys are all like, oh, shit. So sine of x times tangent squared of x equals sine of x. Could you subtract over if this was 2x equals x? Can I subtract over a 2?
No.
What do? You have 5, right? You can't undo that via subtraction. You have to undo it via. Yeah, what's sine divided by sine?
1.
Okay. So far, so good? Okay. How do you undo squaring? Square root. Okay. If I take the square root over an equal sign, what do I have to do? What's the square root of 1? Okay. So now this basically breaks down to what angle has a tangent value of plus or minus 1. Well, tangent's positive in what 2 quadrants? Where is it negative? How many solutions am I going to have? 2. What about 4 solutions then? Right? What angle gives me my
pi over 4?
So it's pi over 4 in each one. Reference angle of pi over 4 in each of the 4 quadrants. So pi over 4. So you're at pi over 4. Second quadrant, you're at 3 pi over 4. Third quadrant, 5 pi over 4. And fourth quadrant, 7 pi over 4. Do not forget when you take a square root, no matter what, it's always plus minus. Always plus minus. Okay. Tangent's negative for the second and the fourth. It's positive first and second. Yep. What's up? You have to be in all four parts, no matter what. Enough! Rude when other people are asking questions. Yep, exact same situation. Yep, that's just what Kelsey was asking. And whenever you get a plus minus, guys, that means, well, obviously when you're solving things, one angle has a positive value. Sine's positive first and second. Cosine's positive first and fourth. They're negatives. You can be finding two solutions no matter what. But once it goes plus minus, you gotta get all four quadrants, no matter what function you're looking at. Okay? Okay? Let's go even further. Two times sine to the fourth x minus sine squared x is 0.
Should you take a sine squared out at some point?
Why would you say that?
Because what we were doing was an option. For the stuff we had on our heads.
Correct. And same. Wouldn't you do the same idea if you had a polynomial? What would you do first there?
Take out the
How can you take out a 2 out of that?
take out the square.
Right. Same thing. You treat it the same way. Okay? You treat it the same way. I can factor out a sine squared. If I take out a sine squared, I'm left with 2 sines minus 1 is 0.
You can divide it as well.
If you did that before, you took out an x squared, you had 2x squared minus 1. If you divide out by x squared, what happens to these solutions?
Undefined.
It's not undefined,
They disappear.
which you can't do. You have two terms that you can set equal to 0.
Yes.
This goes back to quadratics. This goes back to factoring. We're factoring trig functions now. Okay? You have two terms, you set them both equal to 0. And you have to solve them independently. Okay? Alright. First one on the left there, sine squared x equals 0. To undo the square root, what do you have to do? Alright, what's the square root of 0?
0.
Is it plus minus?
No.
So this case here, think of it this way. It's got multiplicity at 0, doesn't it? That's where that comes from. So here you get what angle has a sine of 0? Well, is sine your x or your y value? You should know this right away. It's y value. Where's y 0?
0.
And
1.
so the answer here is at 0 pi. Okay. On the other side then, you work backwards. Add 1, divide by 2. Sine squared x is 1/2. I'm almost done. Now what do I do? Yes, square it. Or excuse me, square root it. So sine of x is plus or minus the square root of 1 over the square root of 2. Well, what's the square root of 1? 1. So I don't even have to really worry about that one. Should I rationalize this?
No.
Nope. No reason to. There's no reason. Sine is opposite over hypotenuse. What triangle am I in? 30, 60, or 45?
45.
I'm in a 45. So it's all four quadrants again, isn't it?
Yeah.
It's all four quadrants because it's plus minus, and it's 45. What's your reference angle at 45? Pi over 4. So this one has 4 solutions on this side of all of your pi over 4s.
Just go up by 2 from 1.
I'm sorry. What do you?
I guess I noticed it just goes up by 2.
It's going up by pi over 2.
Yeah.
They're 90 degrees apart, each one of those. Only for the 45s.
Yeah.
Yes, sir.
So this problem has 6 total possible answers.
5. Should I let her have stuff?
No.
I mean, probably. Yeah, I agree with her.
Oh, watch the email for watch the email for class coach guys.
Okay.
So check your email. One last one here. Does this work the same with inverse functions? Yes. Actually, you know what? I'm going to go to the different one. I want to do this one instead. Excuse me. Sorry. That one winds up with cotangent of 1, so it's pretty basic. In this case here, we have 5 is -3 plus 4 secant theta.
So add 3.
Add 3 and then divide by 4. What do you get? 2. Everybody okay with that? So we get add 3 divided by 4, you get 2, and I'm going to write it as secant theta is 2. I'm just going to put the secant, move it over to the left-hand side. All right? Secant's the reciprocal function of what? Cosine. So if secant's the reciprocal function of cosine, if I reciprocal one side, what do I do to the other side? So what does it become? 1/2. Yeah. All you have to do is reciprocal it. So you get whenever you guys solve these equations, and you've got inverse trig functions, whether it's cosecant, secant, or cotangent. Solve them all the way down to this spot here, then reciprocal it. Don't reciprocal anything until you get to here. Because now you're at a one-step equation. If I reciprocal it, I just got to flip everything. So this becomes cosine theta 1/2. Does that make sense?
No.
Okay. So if you flip one side, you flip the other. That's where that comes into play. All right. So that's basically what this looks like then. Okay. Because if I reciprocal, I get 1 over secant. 1 over secant is cosine. That's where a lot of those identity things come in. Okay? We're just skipping like 15,000 steps.
Yeah, I realized that.
And then from here, I'm assuming you can kind of figure your way through through. Like I was saying, I've got basically a week's worth of handouts. I did not get a chance to write what day after these, so try and keep them. I'm going to pass them out in order. Monday, or like today, then Monday, Tuesday, Wednesday, whatever. If you get them out of sequence and whatnot, I will each day on the calendar I will have the one that I'm talking about. Plus, within the video, I'll mention which one I'm looking at.
Do we have homework tonight on this stuff? Oh.
On the first one I'm handing out to you now, the numbers I wanted you to do, I circled. So at least I did that.
Looks at the paper and it's all.
Yeah, right.
It's a moment.
Now, my figure out obviously, as these come back to you, as you get this one, make sure you write Monday on it. The one I gave you now is today is Friday. This is Monday.
Monday is the 16th.
Yes. Yep.
No, it's just in a song.
Yep, I'm going in order. As I go through, as you guys get these things each day, I will tell you which specific problems and things that I'm looking at, and so on. Yeah, and I'll post everything what I expect it to do. Obviously, as we go through, whenever you have questions, you email, let me know which sheet you're on and all that.
Or no, yeah, this one's four. Yeah, that's Tuesday.
When you started school,
There's a week.
I'll say that. Yes, Thursday.
Probably don't want to watch that. And obviously, hey guys, come on. A lot of this stuff is probably a lot more than what we need. And I'm looking at, yeah. So you've got today's stuff for the ones that we're serving. The stuff we do Monday, I'm going to start talking more about the where the trig identities come into play, about how we have to rewrite certain things within certain values. I don't know if I'll get to within beyond the revolution. I'll probably get to those when we get to Tuesday, and then just keep building through. Which one did you? Friday. Which one?
Wait, you already.
I don't know. Worst case scenario, I'll push more stuff to you. I got the, which one do you need? It says, like I said, I got the email yesterday at about 11:45, 11:50 saying, hey, prepare in the morning, in the afternoon, right around lunch, getting done with lunch. And then we're all like, okay, let's see what we can do. So I just made as many, I went and searched for all the stuff that I had out there from last year. I was looking for other problems, things that I know we're heading into. Yes, ma'am. I have no idea. So, Gus was asking about this earlier, skill checks, tests, things like that. There are ways to push these things out to you via Google Forms. There are ways to make it work, but it has to be within a specific time frame. You only get so much time to do it. So, whether it's coordinated at the same time, which I know could be completely impossible, especially if you're watching other kids or you're doing this, I don't know.
They didn't prepare you enough.
No, it's not that. It's just math is such an oddball subject, whereas with a lot of things, you can push out Google Forms, it's multiple choice tests, you can do this and make it work. With us, there's a lot of crap going on here, so it's so hard to be able to do it. I mean, I can make a multiple choice test out of this stuff, because CUDA can let me do that, and I can push that out, and I can make 60 different versions of it. I can send each one of you your own individual one, so it's not going to help anybody by picturing and sending it back and forth to any person. All right, so I can do all of that. It's just whether or not is it totally feasible to do all of that. So it's up in the air. I promise you, anything that I hear, like I emailed you guys last night. As soon as I knew about all this stuff, I said, make sure you bring everything you have home. Bring every charger you have. Bring your Chromebooks. Don't forget anything, and take that with you. Yes, sir.
I was going to say, calculators, how do we try to
This is all non-calculated, and you're not going to need a calculator for any of the stuff that we're doing because we haven't done. So, hey, that's good for this at least, you know. And like I said, if any section if we do need to do some of the e-learning on it, this is a decent section just to stretch, because as you can see, the mathing of it doesn't change. The weird comes into play when we start worrying about general solutions. And I promise you, I will talk slower. I will try not to use my hands as much. I'll have Moose videotape me as I'm writing it, like behind, as I'm writing on my screen with a stylus.
Also, I want to give you some appreciation. The thing you did field trip we did yesterday. You actually wrote it out. These helped a lot. These helped so much. So I was wondering if you,
I'm still
it's
gonna.
okay if you don't answer.
I'm going
I
to.
appreciate it.
What I was going to say is that a lot of this stuff, I promise, as we get through these things, after a day's of things, I'll make solution keys, post it, check your stuff. So it'll be doing. I'll try and do as much of that as possible because it's gonna be tough to have this interaction. Especially, yeah. Correct, because I'm keeping things in limbo because I can always say, hey, choose some more of this, or I can push you a PDF file or something real fast. I'm just leaving. I only had so much time to make so many copies, and and honest to goodness, I was surprised the copiers worked for everybody yesterday. I should have bought a lotto ticket last night, but I caught that nice fish, so I guess that was it.
Wait, you caught that last night?
Yeah, I caught that yesterday about like 5 o'clock. No, I would not eat anything out of that pond. The pond by my house is probably about the size of this retention pond and the other one put together. So it's not real fresh. I mean, it's kind of gross, but the fish are ginormous in there. They're really good. That's actually a smaller one that I've caught out of that.
My cousin has, like, in next 2 weeks, she's gonna give birth.
Yeah.
So, like, she's worried that her husband is gonna have her wife or not be able to go to the hospital.
I mean, yes, sir. No solutions.
I'm gonna go start one with brain. Like, I'm gonna die and kill my brain. It's always how it happens.